Hello, welcome to my channel. Proper identification of batteries is very, very important. We deal with batteries all the time, but we need to go through and you actually need to be able to understand what a battery does in a system first. So first, what does a battery do in a piece of heavy equipment? Most people don't know this, but it actually stores electric. It stores electric. So when you crank it over, it's used to start the motor. In some applications, it keeps the motor running. Okay, if it has an electronic solenoid on the ejection pump, it'll keep the engine running. Some of your older machines, it doesn't need that, but in most cases, it keeps the engine running. Okay, especially in a gas motor. It runs all your lights and gauges. All right, so without these things, obviously, the battery system doesn't work. Most people never really look at the batteries until it doesn't start the motor, but you need to be able to know what it does in the system. Okay, what are they? What are the two types of batteries? We got a 450 dozer right here. We'll just go in the engine compartment or the battery compartment and pull it out. What is this type of battery? Okay, it looks similar to this, but this is known as what they call a wet cell battery. Right? Most people probably don't even know what this is, but this one here, what type of battery does this thing take? We got to get into the batteries here. What type of battery is this? This type of battery is a, where are you? Oh, maybe they grabbed them both, maybe. Oh, it's a dry cell. Thank you. Okay, so when we're identifying a battery or looking at a battery, the first thing we need to do is be able to identify the posts. I've got one down here. I'll pull up here. All right. So this one's actually got a little bit of an issue. That's what happens when they blow up. But from there, you can clearly see one of these is a positive and which one's a negative. I mean, some people might be able to read the negative sign here versus NEG. But if you look at the tops of the posts, the easiest way to identify a battery is look at the tops of the posts. Okay. In most cases, it might be red. The positive post might be red. In other cases, in most cases, it's larger. If it's a top post like this, the positive post is going to be a larger diameter than the negative post. And the last one here, come on, baby. It's going to have a plus or has a plus sign on it, okay? Sometimes they have a plus sign or they're labeled plus. But you must be able to identify the positive post. The negative post is very much the same. In most cases, it could be black, but that doesn't necessarily mean don't ever go by the colors. Always identify the post if you can. It has a minus symbol on it or a negative symbol, but in this case here, it's always going to be the smaller post. Okay. This is what happens when you short out a battery with a charger. It blows the cylinder off. So, all right. The next slide we got here. So, how many volts per cell is there in a battery? Okay, so each one of these individual blocks right here, these little caps right here, is known as a cell. Sometimes they're labeled like this. Sometimes they have a cap system over the top of them here that has little holes in them, but these are the cells right here. They go down through. These are the cells in the battery. So we need to know how many volts per cell. And what is cranking amps? Okay, cranking amps is the cold cranking amps, how many, what that battery can withstand under cold conditions. But those are two important things. When it comes to identifying the battery system, you got to know how many volts are in each cell to be able to identify how many volt system you're working on. Each cell has 2.2 volts in it. So technically, a 12-volt battery, okay, has 13.2 volts in it. Okay, because there's 6 cells in a 12-volt battery. Count them out here. 1, 2, 3, 6 cells, okay? In most cases, there'll be caps in each one of these cells, so, all right? So if it was a 6-volt battery like the one back here, we know this is a 6-volt battery because there's 2.2 volts in each cell, all right? So this one right here would actually be a 6-volt battery. There's 3 types of systems. There's actually a couple different types of systems that you can identify, but the most basic type there is something similar to this. In this case right here, you would probably have a hot wire. You'd have a hot wire that comes off this down to a starter. Down here, there'd be a starter down here that this would run, or a solenoid that this would go to. And this wire here, would go to a ground. Okay? This is just what they call a ground symbol here. This is the basic 12-volt system. We'll look at a different type of system. This is a parallel system. So in this one here, everything is the same. Same way if you 2 parallel lines, they never intersect. Parallel system is the same way. If you're hooking to this type of system, it's a positive to a positive and a negative to a negative. Okay? Very, very simple. This representation is just to let you know that these are straight through. Positive to positive, negative to negative. Okay? In this type of system, the voltage stays the same. Okay? So if we have a 12-volt system here, it's always going to be a 12-volt system all the way through. If I take a hot wire and I run it to my starter again, and I take a ground up here and I run it down to ground, even though I've got 2 batteries in here hooked up parallel, it's always still going to be a 12-volt system. All right? Really simple. Parallel stays the same. The voltage stays the same. What it does do is it increases the cold cranking amps. It doubles the cold cranking amps. So it gives you more cranking power. That's why heavy equipment, a lot of times you have 2, maybe even 4 batteries in the system hooked up in parallel. Positives all hooked together, the negatives all hooked together. If we're putting a charger on this system, super easy. We'll put the positive on a positive. We'll put the negative on a negative, and we hook it up to 12 volts. Charge away. Okay. I like to try to prefer to hook, if this is hooked up, the hook to the farthest ground and the closest positive. That way you're charging all the batteries and not just pulling off of one. All right. The next system we'll look at is we got a little representation here for parallel. So if we're hooking this up, how are we going to do this? Positive wire should go to positive. This one out to my starter. Negative goes here to negative there. Okay, this one can go to the ground. Series system. This is a little bit more difficult. What are the things that we need to take under consideration when we're dealing with a series system? Okay, first of all, it's serious business. Okay, in most cases, you'll never ever hook a positive to a negative, but in a series system, you definitely will. Okay, you're gonna do exactly that. So in a series system, we are going to take this positive and we're going to hook it directly to that negative right here. Okay. When we do this, we're going to go ahead and we're going to hook this to the starter again, and this one is going to go, oops, some of the colors off, down to ground. Okay. Serious system, serious power here. This system, if these were both 12-volt batteries, which they are, Oops. What did we do to this system? Now we've multiplied this by 2. So now we have a 24 volt system. Okay. 24 volt system, 2 12 volt batteries hooked up in series. If we're hooking a charger to this system, we're going to hook right here, we're going to hook right here, and then we're going to go 24 volts. If we've only got a 12 volt charger, there's only one way to do it. You got to eliminate this wire and then run your ground right here. Okay. You got to hook these up separately. You cannot charge a 24 volt system with a 12 volt charger. Cannot do it. All right. You cannot jump start a 24 volt loader with a 12 volt jumper pack. Okay. You will blow this fuse. All right.